So we're going to go through another problem, which is also in the back of your book. This one is problem number 19. It's on page 368. And actually, it's also one of the individual engagement problems that you'll be working through the Applia software program. If you take a look at problem number 19, you'll see that the data are set up a little bit differently. And so that's the reason that we're working this one in addition to the one that we worked, which was number 12 the first time, because you'll see that it's easily doable to use an ANOVA worksheet to work this particular problem without all of the raw scores available like they were in problem number 12. So in taking a look at problem 19, the data that you have that are organized there is for the three treatment groups. You have the N for each of the groups, and you also have the mean for each of the groups, which isn't relevant or useful for the computation on the ANOVA worksheet. What is going to be useful to us is the sum of squares for each treatment group. But notice off to the right in the last column there, we have the overall N and the overall grand total, and then also the sum of x squared. And so we're going to go work with what we have to complete the information that we have in this ANOVA worksheet, and you'll see that it's very easy to solve this problem just as well and come out with the calculation of an F test. So first off, because we have our G, a 54, we complete that and put that in line 5, and then enter in each of your sample sizes for an overall total N of 18. And then the only other thing on the first page that we can complete is our sum of x squared. Now on the first worksheet, I had calculated, put in the notations to show you that the ANOVA formula process is very much like that sum of squares formula, only on steroids is how I like to describe it. So if you have that one handy, you can refer to it. But for this first set of steps, what's required is what you would be doing if you did it with the raw scores would be squaring each of those raw scores and then summing those new columns up and then adding that up. Here in problem 19, that sum of x squared value is given to us, and so we can just enter it in on line 15. Because we don't have the raw scores, we don't have the totals for each of the raw score, the treatment totals, we can't complete these steps right here. But we're still good. We actually have all the information that we need to put together the information to calculate our sum of squares total, sum of squares within, and sum of squares between. Now, you may or may not have noticed the first time we worked through this worksheet that there were a couple of entries with respect to how to calculate sum of squares within and sum of squares between. And I included them on the worksheet for this specific purpose. You don't always have the same information in each and every instance, but depending upon the information you do have, you can easily get to the bottom line and calculate your F-test. So for our intermediate quantities, we have our grand total of 42 and we have our big N of 18. So for intermediate quantity 1, that works out to 162. We know what our intermediate quantity 2 is, which is 411, but we don't have the information yet to calculate intermediate quantity 3. So with what we do have, we can calculate our SS total. Since we don't have 3, we can't calculate SS within the way we did it the first time, but the alternate formula is to calculate SS within by summing the sum of squares values for each treatment. And if you refer back to the table in the back of your book for this problem, the sum of squares for each treatment group are provided there. So SS 60 for the first treatment group, 65 for the second, 40 for the third, and it totals up to 165. So that allows us to generate our SS within, and then for our SS between, if we have our total, which we do in step number 24, and if we have our within, which we were able to calculate in step number 26, then we put those values together to come up with our SS between value. From there, it's a matter of filling in our degrees of freedom between, degrees of freedom within, degrees of freedom total values, and finishing up with the computation of our mean squares between and within, and finally our F-test. So filling in the ANOVA table with the values that we computed up above, we can do that double check that I described to you in the first problem to make sure that the columns add up to the totals, which they do. The other thing that I did not yet cover, I was waiting to do that with this worksheet, is that the rows also have a system. And if you divide your SS values by your degrees of freedom values, that's where you get your mean square. And you have SS value of 165 divided by 15. That gives you your mean square value of 11. And then mean square between divided by mean square within gives you your F value. And the reason I wanted to stop and point that out for a moment is because you do have problems where you have some information given to you within an ANOVA table and some basic information given in the STEM problem. And if you know how ANOVA tables work, the way the columns total and the way the rows divide, you can quickly and easily fill in the blanks of the missing information and make it a complete ANOVA table. So here we do have a situation where our F value of 3.82 does exceed our table value. So for this problem, we're able to reject the null hypothesis.